In this video, I'll be working through the Limpopo Maths Term 1 Common Test for 2024. Now it starts off with question 1 saying, simplify each of the following without using a calculator and show all calculations. So 1.1, that is actually testing you on laws of exponents. In the bracket, we've got 8a to the power 4 over a, and that entire fraction is raised to the power 2 over 3. Now here's how we can start off. We need to make sure that whatever we have inside the bracket is as simplified as it can be. So we've got 8a to the power 4 over a, and according to laws of exponents, when we are dividing bases that are the same, we subtract the exponents. So what happens with a to the power 4 and a at the bottom, the exponents, which is 4 minus 1, is going to end up giving you a cubed. But at the same time, here's what I'm going to do. I'm going to rewrite 8 as 2 cubed, and then a ends up being a cubed. And the existing exponent will stay outside the bracket. Now, in the next step, we know that when we are raising a power to a further power, we multiply both the powers together. So that's what we're now going to apply. We're going to have a base of 2, multiplying its exponent with 2 over 3. That gives you a squared, or 2 squared, sorry. And the base of a multiplying the exponents 3 times 2 over 3 gives you a squared. Now this we can further simplify. 2 squared is the same thing as 4, and a squared will remain as a squared. So that's your final answer for 1.1. Now looking at 1.2, again, this is testing you on laws of exponents. Let's just start off by rewriting what they've given us. So step 1 is to rewrite all of the bases as products of prime numbers. Within the bracket, we have 27. We can rewrite that as 3 cubed. And the existing exponent will stay outside the bracket. Now, where you have a half, remember the 2 at the bottom has an exponent of 1. So there is this rule that relates to negative exponents that says a to the power negative m is equal to 1 over a to the power positive m. And we are actually using this rule in reverse. So this is what we have. We've got 1 over a to the power m. So we actually have 1 over 2 to the power 1. So we're going to take that 2 to the power 1 and we put it at the top. But when it goes at the top, its exponent now becomes negative. So inside this bracket, 1 over 2, we can rewrite as 2 to the power negative 1. And that negative 2 exponent stays outside the bracket. Then the next rule we're going to make use of to simplify 5 to the power 0. We know that anything raised to the power 0 is 1. So negative 5 to the power 0 is negative 1. We're now going to focus on simplifying the brackets, and how we do that is we apply a law of exponents that says when you are raising a power to a further power, you multiply both exponents together. So applying that to the base of 3, we multiply the exponents. 3 times 2 over 3 gives you 2 plus. Now we have the base of 2. Negative 1 times negative 2 gives you positive 2. And then we have minus 1. Now we can simplify each part. 3 squared is 9. 2 squared is 4. And we have a minus 1. 9 plus 4 is 13. 13 minus 1 is 12. So 12 is our final answer for this question. Now we're on to 1.3, and just by looking at this is testing you on surds. So here's what we're given, and we're going to start off by simplifying each surd. So the square root of 32 can be rewritten as 4 square root 2. The square root of 18 is 3 square root 2, and the square root of 50. Remember, there's this 2 in front, okay? So whatever the square root of 50 is, it's going to be multiplied by that 2 in front. That is going to be 5 square root 2. So when you were introduced to the section at the beginning of first term, you were taught the method of how to use the ladder method, how to get the product of prime numbers so that you can rewrite each base as a product of prime numbers and simplify the surd. But what you're actually given marks for is what you replace each surd with. So to get this, all you have to do is put it on your calculator. You're going to punch in square root 32, it will give you 4 square root 2. So that's how you start off. Simplify each surd using your calculator. Now, before I go on, what we would like to do in our next step is get rid of this bracket. At the same time though, we notice that we have like terms. We've got 4 square root 2 minus 3 square root 2, which is just 1 square root 2, but there's no need to show the 1 in front. Next, we have 2 times 5, which is going to be 10 square root 2. And now gathering like terms, we get 11 square root 2. That cannot be further simplified, so that is your final answer. Now we're on to 1.4. We've got 2 to the power p plus 4 minus 6 times 2 to the power p plus 1 over 5 times 2 to the power p plus 2. So here's what we have. And generally, what we want to do is make sure that all of our bases that have the variable as the exponent, so these bases, we want to make sure that they're all products of prime numbers. So we have 2, which is a prime number, so that's fine. So the next thing we can do is identify what is common. We notice that the exponents look very similar. We've got p plus 4, p plus 1, p plus 2. But if we are to factorize, we need to pull out the smallest exponent as the common factor. Now, between all 3 exponents, the one that is the smallest is p plus 1, which means that p plus 4 as well as p plus 2 can be written in terms of p plus 1. So let's work on doing that. So we are going to focus on splitting up p plus 4 as p plus 1. Now when we do that, we need to multiply it by a base, the same base, with an exponent that when we add gives us p plus 4. So why we're allowed to split it up is because, remember, according to your first law of exponents, when you're multiplying bases that are the same, you can add the exponents. So this is the law working backwards. So here, if we add the exponents, we will get p plus 4. Then we've got minus 6 times 2 to the power p plus 1. We'll leave that as is because we actually want to rewrite everything else in terms of p plus 1. Then in the denominator, where you have the base of 2, you're going to write that as p plus 1 times 2 to the power 1. Because when you add these exponents, you get p plus 2. Now by doing this, you can identify 2 to the power p plus 1 as being common in all of your terms. So in our numerator, we are going to pull that out as a common factor. So if we take out 2 to the power p plus 1, in the first term, we're left with 2 cubed. In the second term, we're left with minus 6. In the denominator, it's not necessary for you to actually pull out 2 to the power p plus 1 as a common factor because you only have one term. So we can actually just leave it there and it would still cancel out. So that is actually your next step. Your whole aim of factorizing is so that whatever you've pulled out as a common factor can cancel out with itself from the denominator. Now let's simplify what we're left with. So from what we're left with, 2 cubed is 8, so we have 8 minus 6 at the top. At the bottom, we've got 5 times 2, which is 10, So 8 minus 6 is 2. We've got 2 over 10, which simplifies to 1 over 5. So that is it. So 1.5 works in a similar way. We've got variables as exponents, and we need to make sure that the bases are products of prime numbers, which some of them are not. So we need to change 9, we need to change 18. The 3 and the 2 are fine though. Okay, so let's do this. We are going to rewrite 9, and that can be replaced with 3 squared. And remember, I have mentioned this in other videos, that whenever you replace a base with its product of prime numbers, you always replace it with the brackets. If it had an existing exponent, its existing exponent goes outside the bracket. So your next term is fine because 3 is a prime number, so that would stay as is. In the denominator though, 18 can be rewritten as 2 times 3 squared, and its existing exponent goes outside the bracket. Then we are multiplying by 2 to the power negative x. Now to get rid of the brackets, we are going to apply laws of exponents. We know that we multiply the exponents together, giving us 3 to the power 2x plus that second term. In the denominator, 2 here has an exponent of 1. So 1 times x gives you x. And we multiply the exponent on 3, so 2 times x gives you 2x. And then you've got 2 to the power negative x. Now at this point you realize that there is something common between all of your terms, that is 3 to the power 2x. But to further identify it, we are just going to split up the exponents in the second term. So we're going to write that as 3 to the power 2x times 3 to the power 1. And the denominator, everything is split already, so we can just leave that as is. Now by doing this, you can clearly see that 3 to the power 2x is common in all of your terms. So let's pull that out as a common factor. We're taking out 3 to the power 2x. In the first term, we'll be left with 1. In the second term, we're left with 3. At the bottom, we don't actually have to factorize since it's all one term. There's no plus or minus in between. So we can leave it like that and it would still cancel out, which is what we do next, right? So we cancel them out. Now when you simplify your numerator, you've got 1 plus 3, which gives you 4. And when you simplify your denominator, you are multiplying bases that are the same. So you're going to add the exponents. We've got x minus x, which gives you 0. So we have 2 to the power 0 at the bottom. And anything raised to the power 0 is 1. So ultimately, we end up with 4 as the answer. So for 1.6, we are subtracting fractions from each other, and this is actually something that is now testing you on what you learned in grade 10. So simplifying fractions was part of your algebra section in grade 10, term 1. So they've decided to bring it back here. So this is what we're given. And as a general first step, we always start off by factorizing wherever possible. So in our first fraction, we cannot further simplify through factorizing, so we're going to keep that as is. But in our second fraction, when we look at the denominator, we realize that we have x squared minus 9, which is difference of 2 squares. So to factorize that, we're going to put in x and x into our brackets, and the square root of 9 is 3, so we fill in 3 and 3. Remember, one bracket gets a plus, the other bracket gets a minus. Now at this point, if any of your brackets in your numerator and your denominator are the same, they can cancel out with each other. So we realize that we've got x plus 3 at the top as well as the bottom, so they cancel out. So here's what we're left with. In the second fraction, we've got 1 in the numerator and x minus 3 in the denominator. Now here's the thing about adding and subtracting fractions. And this is the same rule that you've learned in primary school when you were first introduced to adding and subtracting fractions. You learned that you need to get an LCD, a lowest common denominator. But how do we get a lowest common denominator if we've got variables? It's not that easy to see what's common in both of them. Instead, this is the rule that we use. Okay, so the rule is when adding or subtracting fractions with different denominators. So here you can see that your denominators are different. I've got B and D. Here's how we get the new denominator. So to get the new denominator, we multiply both denominators together. And to get the numerators, we cross multiply. So we take the one denominator and multiply across with the numerator. Here we have D times A, which I've written as AD. Whatever the sign is in between, you keep the same sign. If it's a plus, you keep a plus. We have a minus in our question, so we would have a minus in between the numerator. And then we cross multiply the other way, so B times C gives you BC. Now let's apply this to what we have. So getting the new denominator, we are going to multiply both of these together. We're then going to cross multiply. So we're going to take this x minus 3 and multiply it across with x minus 3. Because it is being multiplied with itself, we can just say x minus 3 all squared. Then we keep the minus in between and we cross multiply the other way. We have x plus 3 times 1, which is just going to be x plus 3. Now let's simplify. So there is actually no need for you to multiply out your denominator. You can keep it as those two brackets. Simplifying the numerator, we've got a binomial squared, which is going to result in a trinomial, that is this x minus 3 all squared. To get the first term, we square the first term. To get the second term, we multiply both terms together and we times by 2. That is going to give us negative 6x. To get the third term, we square the second term, so we have plus 9. Now we're going to take this negative and multiply into the bracket with both terms. It gives you minus x minus 3. Let's gather like terms. So we've got x squared. We have minus 6x minus x, which is minus 7x. And we've got 9 minus 3, which is 6. And remember here, your denominator stays as is. So if you'd like, you can actually attempt factorizing your numerator, but it is not necessary. So this is your final answer. Question 2 now requires you to solve for x. So 2.1.1, we've got 3x minus 5 and x plus 1 is equal to 0. Please do not multiply out these brackets. If you do, you will get a trinomial when you gather like terms, but you'll have to factorize that and you're going to end up with the same brackets again. Instead, what they've done is they've already factorized for you. So all you have to do is take each bracket and equate it to 0 separately and solve for x. Okay, so doing that, we get 3x minus 5 equals 0, or x plus 1 is equal to 0. Now, solving in the first equation, we can take the 5 over to the right, it becomes positive. We're then going to divide throughout by 3, so we get x as 5 over 3. In the second equation, we're going to take the plus 1 over to the right, and we get negative 1. So those are the two values of x. Now 2.1.2, we are given a quadratic trinomial, 3x squared plus 5x plus 1 is equal to 0, and it says correct to 2 decimal places. So we know that that is an indication that we need to use the quadratic formula. Since the equation is already in standard quadratic format, we can just write out the quadratic formula and substitute. So substituting, our b value is 5, a is 3, c is 1. And in the denominator, we'll have 2 times 3. Now when we simplify, we get negative 5 plus or minus square root 13 over 6. And when we calculate this, the values that we get as x is equal to negative 0.23 or x is equal to negative 1.43. Now for 2.1.3, we've got 3 square root x plus 2 minus 1 is equal to 2x minus 6. Remember that when you're solving for x and you have the surd kind of question, your aim is to isolate the surd. So the term that has the surd needs to be alone on the left-hand side. Okay, so to do that, let's take that minus 1 over to the right. When it goes over, it is going to add, so we have minus 6 plus 1, which is minus 5. Now, what is the aim of isolating the surd? The whole aim of isolating the surd is so that you can square both sides to get rid of that square root. Now, on the left-hand side, the square is going to act on the 3 and give you 9. And the square is going to act on the square root and cancel it out. So you're going to be left with x plus 2. Because remember, the 3 was multiplied with the surd. So it ends up being 9 times whatever was underneath the square root. On the right-hand side, binomial squared is going to result in a trinomial. We will have 4x squared minus 20x plus 25. Here's how we get that. Remember, to get the first term, we square the first term. To get the middle term, we multiply both terms together and times by 2. And to get the third term, we square the second term. Now on the left-hand side, let's just simplify that by taking the 9 and multiplying into the bracket with both terms. We get 9x plus 18. Now let's get everything over to one side. Since my ax squared term is positive on the right, I'm going to take everything over to the right-hand side. Taking the 9x over to the right, it's going to subtract. We get negative 29x. Taking the 18 over to the right, it will subtract. 25 minus 18 gives you 7. Now, to solve for this, you could either factorize or you could use a quadratic formula, but I would suggest use a quadratic formula because this is a complex trinomial. We may not necessarily be able to solve for it on our own. So let's just do that, right? We're going to write out the quadratic formula and substitute. So here's what we have. Now, solving for x, the two values that you get is x is equal to 0.25 or 1 over 4, or x is equal to 7. But remember, when it's this type of question where you have the square root in it, you always need to substitute your values and see if they work out. Now, when we substitute these values, we realize that 1 over 4 does not work out. We do not get the left-hand side being equal to the right-hand side, meaning that 1 over 4 is not applicable, but 7 does work out, which means that 7 is the answer. Now for 2.1.4, we are subtracting fractions. So I've showed you in, it was 1.6, how we get it as one fraction. So we're going to do that. We're going to focus on getting the left-hand side as one fraction first. Okay, here's what we have. And to get it as one fraction, we know that to get the new denominator, we multiply both denominators together. And for the numerators, we cross multiply. So we're going to have x times 3x plus 1. We keep the same sign in between and we cross multiply the other way. We'll have 2x plus 4 times x minus 1. And on the right-hand side, we have 4. Now, since we want to solve for x and we don't want to have x in the denominator, what we can do is take this denominator and multiply it across. So on the right-hand side, it is going to multiply with the 4. And on the left, we are going to simplify the numerator. So we're taking the x and multiplying in. X times 3x will give us 3x squared. x times 1 would be positive x. Now, let's multiply these brackets first. 2x times x will be 2x squared. 2x times negative 1 is minus 2x. Positive 4 times x is positive 4x. And positive 4 times negative 1 is negative 4. In the next step, let's take this negative and multiply into the bracket. So here's what we get when we do that. And on the right hand side, I am going to multiply out both the brackets. So using the FOIL method, I get 3x squared plus x minus 3x minus 1. Now on the left hand side, I'm going to gather like terms. I've got 3x squared minus 2x squared, which is x squared. We've got x plus 2x, which is 3x, minus 4x is negative x, and our constant is 4. On the right hand side, we are going to take that 4 and multiply into the bracket with all 4 terms. Actually, let's simplify this, right? We've got x minus 3x, which is negative 2x. Taking that negative 2x and multiplying with 4, we get negative 8x minus 4. Okay, one thing that I realized here was the question had a negative 4 on the right. So I'm just going to correct what I've got. Basically, all of this is negative. So we've got negative 4, negative 4, negative 4. And now obviously that changes the signs of what we have, right? This becomes negative 12, positive 8, and positive 4. Okay, so that's fixed up. Now let's get everything over to the left. Taking the negative 12x squared. When it goes over to the left, it is going to add with the x squared to give you 13x squared. Taking the positive 8x to the left, it's going to subtract. We have minus x minus 8x, which is minus 9x. Taking the 4 over to the left, it is going to cancel out. So we're left with 0 on the right. Now to solve for x here, in both of our terms, x is common. Let's pull out x as a common factor. In the first term, we're left with 13x. In the second term, minus 9. And that is equal to 0. Now, taking each part and equating it to 0 separately. So the first part, we have x is equal to 0. In the second part, let's take the negative 9 over. It becomes positive. Let's divide throughout by 13. So we get x as 9 over 13. So those are your two values for x. We're now on to 2.1.5. We have 7 to the power x minus 1 is equal to 49. Now for questions like this, where we have x as the exponent, we need to start off by making sure that the bases are products of prime numbers. So on the left hand side, 7 as the base is fine because that is a prime number. But on the right hand side, we can rewrite 49 as, let's just rewrite that as 7 squared. Now that the bases are the same, they cancel out with each other. And we equate the exponents, so we have x minus 1 is equal to 2. To get x alone on the left, let's take the negative 1 over to the right. It is going to add on, so we have x is equal to 3. Now again, when it comes to questions where you're required to solve for x, and if you're not sure if your x value is correct, all you have to do is take that x value, substitute it into the question, and you should get the left-hand side equal to the right-hand side. So this works out. So x is equal to 3 is correct. So now 2.1.6 is an inequality, and we've got 2x minus 3 times x plus 1 is less than 3. When it comes to inequalities, just like equations where we need to solve for x, we can only take the brackets and equate it to 0 if there is a 0 on the right hand side. But here we have a 3. So what we actually need to do is expand the brackets on the left and take the 3 over to the left. So let's do that. We're going to have 2x times x, which is 2x squared. 2x times positive 1 is positive 2x. Negative 3 times x is negative 3x, and negative 3 times positive 1 is negative 3. At the same time, let's take this 3 from the right hand side over to the left. When it goes over, its sign changes, it becomes negative 3, and now we're left with 0 on the right. Let's now gather like terms. We have 2x squared. Then we've got a plus 2x minus 3x, which is negative x. And negative 3 minus 3 is negative 6. All of that is less than 0. Now this can be factorized, but it is a complex trinomial. So if you're not good at factorizing complex trinomials, you can always use your quadratic formula. Okay, I'm just going to go ahead and factorize this. So we've got 2x squared. My factors are going to be 2x and x. And for negative 6, I'm going to use positive 3 and negative 2. So the factorizing that I've used to get these brackets is something that you learned in grade 10. I'm just going to show it to you here in case you want to know how to do this, but you're not sure how to. What we do is we take factors of the first term. So 2 factors of 2, I'm taking 2 and 1. We take factors of the last term where I've chosen positive 3 and negative 2. And then we cross multiply. So we're going to have 2 times negative 2, which gives us negative 4. We have 1 times positive 3, which gives us positive 3. And then we add vertically. So we've got negative 4 plus 3, which gives you negative 1. Now the value that you get when you add vertically, this negative 1 needs to be the same as the coefficient of the middle term. If it matches, then it means that these factors are your brackets. Since the first column was for x, it's actually 2x plus 3 and 1x minus 2. So you use that as your brackets. But still, if this is a bit too much for you to contain, a bit too much for you to remember, it's fine. You have your quadratic formula in grade 11. So you can just sub into that. But please remember that this is an inequality question. At no point in the question are you allowed to use an equal to sign. So you cannot. Instead, the values that x would be equal to, these are now known as our critical values. So from your first bracket, you would get x equal to negative 3 over 2. So you're not allowed to say x is equal to negative 3 over 2. That would be wrong. You're not allowed to say that. Instead, what we do is we have them as critical values. So x would be equal to negative 3 over 2, and x would have been equal to positive 2. Now, from your critical values, you're going to write down your answer. Since we've got a less than in the question, this is how our answer would be written. We have one answer written together, where we read it as x lies between, smaller value goes on the left-hand side, bigger value goes on the right-hand side. So that's it. Question 2.2 says solve for x and y simultaneously. So we've got 2x minus 2 is equal to y, and our second equation is 2x squared plus y squared is equal to 2. So here's what we're given, and we notice that in the first equation, we already have y as the subject of the formula. So there is absolutely no need for us to further simplify this first equation. So we can use it as is, and we are going to take that value for y and substitute in the second equation where we have y. Doing so, here's what we get. So we've substituted in place of y. And remember, y was squared, so we have this bracket squared. Now we're going to expand this bracket. Here's what we get. Now remember how we do this. We had a binomial squared. To get the first term, we square the first term. To get the middle term, we multiply both terms together and we times by 2. To get the third term, we square the second term. Now what we're going to do is, let's simplify. Let's get everything over to the left. We have 2x squared plus 4x squared. That's going to be 6x squared. Then we've got a minus 8x. Let's take the 2 over to the left. It is going to subtract. 4 minus 2 is 2. So how you want to solve for x from here is entirely up to you. You can factorize if you'd like. You can make use of the quadratic formula. I would actually encourage you to use the quadratic formula here, seeing that this is a complex trinomial, so factorizing might be a bit tricky as well as time consuming. So let's go ahead and use the quadratic formula. So here's the formula, and now let's work on the substitution together. We've got negative into b, and our b value here is negative 8. Then plus or minus the square root of negative 8 all squared, minus 4 into a is 6, c is 2, all over 2a, so all over 2 into 6. Now let's simplify. Simplifying the numerator, we get negative times a negative 8, so that gives us a positive 8 underneath the square root. So if you put everything that's underneath the square root on your calculator, you get 16. In the denominator, 2 times 6 is 12. Now let's first work with the plus. So using the plus, I get x is equal to 1. And then working with the negative square root, we get 1 over 3. So those are our two x values. But now that we know what x is, remember you still need to solve for y. So we're going to take those x values and substitute into the previous equation so that we can get y. That's going to be y is equal to 2x minus 2, so 2 times 1 minus 2. And here y is equal to 2 times 1 over 3 minus 2. That leaves us with y as 0 or y as negative 4 over 3. Now we're on to question 3. And this is testing you on nature of roots. 3.1 says, determine the values of m for which the following equation has equal roots. So they've given you x squared minus 3x minus m is equal to 0. So remember that your first step is to get the equation in standard quadratic format, which it is given to us in. But once you have it in that format, you need to identify a, b, and c. A is always the coefficient of x squared. So here a is 1. B is always the coefficient of x, which in this case is negative 3. And c is any term that does not have x in it. So c represents your constant. Here we have negative m. Your next step is to write out the condition. So we need equal roots. We are going to say 4 equal roots. And the condition here is that for equal roots, the discriminant must be equal to 0. Let's further expand. We know that the discriminant is b squared minus 4ac. Let's substitute in here. B is negative 3. A is 1. C is negative m. And all we've got to do from here is solve for m. So let's simplify. Negative 3 all squared is 9. We've got negative 4 times 1, which is essentially negative 4. Times that by negative m, we get positive 4m. We'll keep the 4m on the left. Let's take the 9 over to the right. It becomes negative. Then we are going to divide both sides by 4. So we get m is equal to negative 9 over 4. That is our final answer. Now 3.2 says, show that the roots of mx squared plus mx minus 12 equals 0 will be real and unequal if m is greater than 0. This question is phrased very differently. You are not required to solve for m, but you are told that m is greater than 0. In maths, if any value is greater than 0, it means that it is positive. So what we need to do is, we have to work with the discriminant and somehow show that from the discriminant, if the values of m are positive, it will always yield real and unequal roots. Okay, so let's start off with this equation identifying a, b, and c. We'll then substitute into our discriminant and simplify. Okay, so here's what we have, and identifying a, remember a is always the coefficient of x squared, which here we have m. B is the coefficient of x, which is m as well. C is any term that does not have m in it, so C is negative 12, which is your constant. Now we're going to write out a condition, and the condition is going to be for real and unequal roots. So the condition is always based on what the question requires from you, okay? For real and unequal roots, your discriminant has to be greater than 0. So let's expand. B squared minus 4ac is greater than 0. And now let's substitute. So according to what we have, m, or b is actually m, so that's going to be m squared. Minus 4, a is m, c is negative 12. And all of that must be greater than 0. Now we get m squared. Here we've got negative 4 times m, which is negative 4m. We're going to multiply that by negative 12. So we get positive 48m is greater than 0. Now we need to answer the question based on what we have. In order for you to get real and unequal roots, your discriminant must be greater than 0. So how do we know that what we have on the left-hand side is always going to be greater than 0? The fact that m is positive, firstly. If you've got a positive number, so let's focus on the first term. Focusing on this first term, we have m squared. And even if m was negative, when you square a value, it always becomes positive. So one thing you notice here is that m squared is always positive. Okay? M squared is always positive. And since m is greater than 0, then m squared is also greater than 0. Okay, so we've analyzed the first part. Let's now analyze the second part. We've got positive 48m. Now what we know is that m itself is greater than 0. That was given to us. Okay? So for the second part, we are given that m is greater than 0. And you guys know that positive times a positive is always a positive, which means that positive 48m is greater than 0. In fact, it will always be positive. Now, what this means is that since both of your terms are positive, if you're adding a positive value onto another positive value, it is always going to give you a positive answer. And why are we so worried about seeing that it's positive? It's because we need real and unequal roots. And we only get real and unequal roots when the discriminant is greater than 0. Greater than 0 means positive. Now, based on this explanation that we gave here, we can say, therefore, the discriminant is greater than 0. Therefore, the roots are real and unequal. So yeah, this question was different in the sense that you were not solving for m at all. You were just substituting, simplifying, analyzing what you have, and seeing if each term gives you a positive value. So ultimately seeing if this left-hand side is going to be positive, which yes, it was. So that means that the discriminant is greater than 0. Therefore, our roots are real and unequal. We're now on to question 4, and we are starting off with trigonometry. So 4.1 says, if cos 15 degrees is equal to P, express the following in terms of P. So we know that this is the question where we definitely have to draw a triangle. Since we are given 15 degrees, that is going to lie in the first quadrant. But let's make sense of the equation that we have first. So here's what you have. Cos 15 degrees is equal to P. And think of this as a fraction. It's actually P over 1. Now, we know that we are working in the first quadrant, so we are going to draw a triangle in the first quadrant according to the butterfly diagram. So this is what the orientation of the triangle should be like. Remember, it definitely has to be a right angle triangle. once you have your triangle drawn, fill in the information that you're given. So according to what's given, we've got adjacent over hypotenuse. The angle that we're working with is 15 degrees. In terms of 15, here's adjacent, here's hypotenuse. Now you're going to use the theorem of Pythagoras to get the remaining side. So let's do that. We have r squared is equal to x squared plus y squared. R is the hypotenuse, which is 1 in this case. 1 squared is 1. X is always your horizontal distance on your triangle, which is p squared. And then y is unknown. Let's take the p squared over to the left. We've got 1 minus p squared is equal to y squared. To get y alone, let's square root both sides. So we have y as 1 minus the square root of 1 minus p squared. Now, since you have the angle given, we know that it's 15 degrees. We can actually calculate the remaining angle on the triangle just in case we need it. Now, you know that angles in a triangle add up to 180. So we can say 180 minus 90 minus 15, and we get 75. Now that we have all the angles and all the sides of the triangle, we can now go on to the questions. So here's 4.1.1, we need cos 195. Now, seeing that we need cos 195, obviously it is not on the triangle, so we need to reduce this. If you are given an angle bigger than 90, your aim is to apply reduction formula onto it. 195 lies in the third quadrant, so let's use 180 plus. It's going to be 180 plus 15 degrees. Now, to reduce this, 180 plus lies in the third quadrant where cos is negative. So it's negative cos 15. And we've got the negative sign. We can just get cos from the diagram, or actually what was given to you, adjacent over hypotenuse, p over 1, which is just p. So the answer for 4.1.1 is negative p. Now in 4.1.2, we need to calculate sine 105 degrees. And again, that is bigger than 90, so let's reduce it. But remember that when you reduce, you are trying to reduce in terms of what you have on your triangle. So 105 lies in the second quadrant. You can use 90 plus, but I'm going to use 180 minus. So that's going to be 180 minus 75. Now 180 minus lies in the second quadrant where sine is positive. So that becomes positive sine 75 degrees in terms of the diagram. Let's go to 75. In terms of 75, sine is opposite over hypotenuse. That's going to be p over 1, which is just p. And 4.1.3, we need to get sine 15 degrees. So to get sine 15 degrees, let's go to our diagram. Here is 15. Sine is going to be opposite over hypotenuse. It's going to be the square root over 1. But since it is over 1, we don't actually need to write it. We can just say 1 minus p squared. If you want to put the 1 at the bottom, it doesn't change the answer. You can leave it there. But also, without it, that's fine as well. So that's our value for sine 15 degrees. Now 4.2 and 4.3 are quite similar. We need to simplify. But focusing on 4.2, we notice that we're given a lot of reduction formula in there. Now I've actually covered quite a few questions on this for grade 11. So if this is something that you struggle with, please make sure that you check out those videos. All the questions were taken from past papers, so that would also serve as good practice for you. So here's what we have for 4.2. I've mentioned this in previous videos and I'm going to say it again. This type of question, where you are required to simplify, tests you on all your knowledge of trig. Not only does it test you on reduction formula, but it also tests you on negative angles as well as special angles now and then. You need to know your cast diagram. You need to know the fractions For your special angles, you need to know how negative angles work. And you also need to know how to work when we've got trig ratios that are squared. Okay, so this is a good way of testing you on the entire section. Now here's how we work with this. We are going to focus on one part at a time, starting off with sine of 180 minus a. 180 minus lies in the first quadrant where sine is positive, so that becomes positive sine a. Next to that, we've got tan a, which we probably need to expand later on. For now, I'm going to keep it as is. I'll just keep that as tan a. Next to that, we've got sine of 90 plus. 90 plus lies in the second quadrant where sine is positive. However, 90 changes sign into cos, so that becomes cos a. In the denominator, you've got tan of 180 plus a. 180 plus lies in the third quadrant where tan is positive, so that becomes positive tan a. Next to that, you have sine of a negative angle. Sine of a negative angle is minus sine of that angle. Then you've got cos of a negative angle. Cos always stays positive. Even when it's paired with a negative angle, it does not change. That's just going to be cos a. So positive cos a. Now there's something interesting that you notice. In your numerator, you've got sine a as well as in the denominator. But remember, it was negative, so the negative isn't falling away at the moment. In our numerator, we've got tan a that cancels out with tan a from the bottom. We've got cos a that cancels out with cos a from the bottom. Now, once everything cancels out, ultimately, what we're left with here is negative 1. And that is your answer. Now, I always say this to my learners that when you're doing these questions in trig where you're required to simplify, your first step carries the most marks. This question was for 6 marks. Your first step carried 5 of those marks. And your 6th mark was obviously for your answer. Whenever you apply a reduction formula, a negative angle, a special angle, whatever rule it is from trig, whenever you apply any rule, you are awarded 1 mark for that. So every single thing that we did in this numerator, remember we changed. So we got sine a, we kept tan as is, right? So for the tan a part at the top, there was no mark for that. But to get sine a, cos a, in the denominator, tan a, negative sine a, cos a, those were 5 marks. And your 6th mark was for negative 1. Okay, let's go on. We are now on to 4.3. Very similar to 4.2, but this is now a 9-mark question, so that's quite a bit. Let's start off by rewriting what we're given. So we're going to work in a similar way where we work through each part. I'm going to start off by focusing on cos. In the numerator, we've got cos of x minus 360. So here's the thing. If it looks like a reduction formula, but it's swapped around, and the value is negative, you add 360 onto it. So that always works like that. When we add 360, what happens is negative 360 plus 360 cancel out. We're just left with cos x. Now focusing on the second part, we've got tan of 180 minus x. Now, 180 minus lies in the second quadrant where tan is negative. So that becomes negative tan x. Next to that, we've got cos of 90 minus x. 90 minus lies in the first quadrant where all your trig ratios are positive. However, because it's 90 paired with cos, 90 changes cos into sine. So that becomes sine x. In the denominator, we've got sine of 180 plus x. 180 plus lies in the third quadrant where sine is negative. So that becomes negative sine x. Now next to that, we've got this bracket, which might seem a little confusing at the moment, but inside the bracket, the 1 is just going to stay as is. And what we have here is cos squared of negative x. So I just want to show you how this part works, right? Excluding the minus in front of the cos. So just focusing on cos squared of negative x. I want to focus on the square that's on it. The square tells you that whatever answer you get, that answer is going to be squared. So essentially what we have is cos of negative x, and we know that cos of a negative angle becomes positive cos of that angle. But the square tells you that this answer is going to be squared, so ultimately this becomes cos squared x. Now here we've got the minus in front, so we're going to keep the minus, it's 1 minus, and then we put the answer, cos squared x. Now before we do anything further, what we realize is that we've got sine x in the numerator, and we've got sine x in the denominator. They can cancel out with each other. At the same time, we've got a negative in the numerator and a negative in the denominator. Those can cancel out as well. Or you can look at it as being negative divided by negative, which gives you a positive. Now let's simplify. So in our numerator, we have cos x. That tan x, I'm going to rewrite as sine x over cos x. There's nothing next to it. And in the denominator, where we've got this 1 minus cos squared x, that is actually equal to sine squared x. So here's where it comes from. You know your identity, sine squared x plus cos squared x is equal to 1. This identity is manipulated. If we keep the sine squared x on the left-hand side, and we take the cos squared x over to the right where it becomes negative, notice that this is now the same thing as that denominator. So that denominator can be replaced with sine squared x. So just remember that it's really important for you to remember that this identity can be manipulated. So at the bottom, we've got sine squared x. Now at the moment, we notice that the cos x and the cos x cancel out. Sine will also cancel out, but I'm just going to show it to you a bit different. If we now write out what we're left with, in the numerator, we have sine x. In the denominator, we've got sine squared x. Now, the sine x in the numerator cancels out with one of the sine from the denominator. So what we're left with is 1 over sine x. And since that cannot be further simplified, that is your final answer. So we are done with question 4. We're on to question 5, and 5.1 says prove that we've got sine x plus cos x all squared is equal to 1 plus 2 sine x cos x. So this is the kind of question where you need to prove the left-hand side is equal to the right-hand side. So for questions like this, you always start off by writing down which side you're going to start working with. In this case, it's the left-hand side. We've got this bracket squared. Now we know that a binomial squared is going to result in a trinomial. To get the first term, we square the first term. That gives us sine squared x. To get the second term, we multiply both terms together and we times by 2. That gives us positive 2 sine x cos x. To get the third term, we square the second term. That is positive cos squared x. Now based on what you have here, notice that you have this term sine squared x plus cos squared x, and you have an identity. Sine squared x plus cos squared x is equal to 1. So those two terms can be replaced with 1. Now also take note that these terms in the identity does not necessarily need to be next to each other. They can even be something in between them, like what we have here. But when we gather them, they give us the identity. So it is equal to 1. So replacing those two terms with 1, we have 1 plus 2 sine x cos x, and that is actually equal to the right-hand side. So we say equals to the right-hand side, and we are done. Now for 5.2, we've got a similar question. Here again, we need to prove left-hand side is equal to the right-hand side. So here's what we're given. We're going to start off by working with the left-hand side. And what we can do is, because we are adding two fractions with different denominators, we can focus on getting this as one denominator. So to do this, we multiply both denominators together. And then we cross multiply. So we're going to have sine x times sine x, which gives us sine squared x. And then we're going to have this denominator 1 plus cos x multiplying across with cos x. So it's going to be cos x times 1 plus cos x. Now let's expand that numerator. We've got sine squared x plus cos x times 1 is cos x. Cos x times cos x is cos squared x. And your denominator stays as is at the moment. Now we're going to apply the same thing that we did in the previous question, where in the previous question we had sine squared x and then cos squared x, and we replaced it with 1. We have the same thing here. Here sine squared x plus cos squared x. So we know that that is 1. So numerator is 1 plus cos x. Denominator stays as is. But something important that you now notice is that your entire numerator is the same as the bracket in the denominator. So they can cancel out with each other. What we are now left with is 1 in the numerator, sine x in the denominator, and that is equal to the right-hand side. So we have managed to prove this identity. Now 5.2.2 says, for what values of x in the interval where x lies between 0 and 360 degrees will the identity be undefined? And here's the thing. When they ask you where the identity will be undefined, here's how you do it. Since you're working with fractions, you are going to look at values of x where your denominator is equal to 0. Because we know that, right? In a fraction, the only time a fraction is undefined is when the denominator is 0. Now, we need to think about this carefully. Looking at this denominator, we're going to ask ourselves, for what values of x is this denominator equal to 0? Now, the best way to do this is to think of sine x in terms of a graph. Think of trig functions. And sine x gives you your basic sine graph. So I'm just going to draw that. We are not writing down the answer just yet. We're trying to get to the answer. So here's what your basic sine function looks like. So this is what it looks like. And there are 3 points, and I've only drawn 0 to 360 because that is the interval that we're working with. There are 3 values here, or 3 points, where your graph is equal to 0. That is obviously where the graph cuts the x-axis. Those points are 0, 180, and 360. So if we take any one of those 3 values and we substitute in here, and you can actually try it out on your calculator. 1 over sine 0, 1 over sine 180, 1 over sine 360, you will get math error for each of those. That tells you that your fraction is undefined. So your answer for 5.2.2 is x is equal to 0, 0 degrees, x is equal to 180 degrees, or x is equal to 360 degrees. So those are all the x values that makes this fraction undefined. So that is the end of this paper. Please remember to like, subscribe, and turn on your notifications for more content.